Hey, this is Mrs. Slauson. This is our first video that we're going to be doing together. So the idea is you've got a front and a back, and we're just going to be starting with the front page. And the idea is we, in this video, are going to be doing two problems together, and then I want you to find a partner and do the next two problems. And then without a partner, I want you to do the last four problems. When you're done, you may check your answers with the sub, or Mrs. Lambert will just share the answers with you. So let's go ahead and get started. So the idea of radicals is we are going to be discussing the third rule, and that nothing perfect can be in the radical. They want as little inside that check mark as possible. So first thing I'm going to be doing in the first problem is making a factor tree, because it is much easier if we treat every part under the radical the exact same way. So here goes my factor tree for 240. So many different ways you could get this factor tree going, but I chose to use, put it right over here, I chose to start with 30 and 8, and then I took the 8 down into 4 and 2, and the 4 I broke down into 2 and 2. So with 30, I'm going to break it into 6 and 5, and then 6 I'll break down into 2 and 3. And it doesn't matter how you make the factor tree, we will all have the same numbers. So just circling the numbers that I'll be using, these are the prime numbers when your branch can't go any further. And now I'm going to rewrite this problem. Instead of 240, I'll be writing it with its prime factors. So I'll be writing it as 2 to the 4th because I have 4 2 circled, 3, and I'll put an exponent with the 3 and an exponent with the 5, and just recopying what's already in there. All right, so now I'm going to make my two branches. I'm going to make my perfect group, not branches, and my non-perfect, and I always put the perfect one first. And so now I just go through each part under that check mark under the radical and take as much as perfect and put it in the first set. So of my 4 2s, I will make 3 perfect, and that means 1 is not. That gives me a total of 4 2s between the two radicals. The 3, there is not enough to be perfect. There isn't enough for the 5 to be perfect, so they're going in the non-perfect. With my x to the 5th, I can make 3 of them perfect, but that means 2 of them were not. With y to the 9th, they are all perfect. And with my z to the 10th, I can make 9 become perfect, and that means 1's not. And again, what makes them perfect is the fact that 3 can go into all of these exponents. And when I mean into, I'm talking about division. So everything that's perfect is going to come out, and I will sign their exponents. So 2 will get a first exponent. If you want to write it, you don't need to. X would get a first exponent. So again, I can write that one. Y gets a third power, and Z gets a third power. And then I put a little multiplication dot, and what's not perfect is everything in here. I will do a little bit of cleaning up. I'm going to take 2 and 3 and 5 and just multiply that into 30 with the x squared and z. And this doesn't look much better than what we started with, but we have followed the rule that nothing perfect can be under the radical. So same thing for number 5. I'm going to start with my factor tree. So 486, and again, you can always use your factor program to help you get started, but put 486 right here. So starting with 486, 1 second. Let's see. I think a great place to start is just with 2. So I'm going to start with 243 and 2. And then I'm going to break 243 down into 81 and 3, and I'll break 81 down into 9 and 9, and all those 9s can be broken down into 3s. So again, good idea if you want. Just circle all your prime numbers so you know that these are what's going into your houses, into your radicals. And now I'm going to rewrite it. So instead of 486, I'm now going to have 3 to the 5th power along with a 2, and which you can put an exponent of 1, x to the 6th, and z to the 15th. So now I'm going to make my perfect and my not perfect. So 5th root and a 5th root here. So my 3s, they are all perfect. My 2s, I don't have enough to be perfect. Of my 6 x's, 5 of them can be perfect, and that makes 1 not. And of my 15 z's, these are all perfect. So now just take everything perfect out and give it an exponent. So 3 will get a first power, x will get a first power, which I'm not going to write because you don't traditionally write the first power, and z will get the third power. And again, I'm just getting that third power by seeing how many times 5 goes into 15. And then there's a little my multiplication dot to separate that out, and when I'm done, I get this. So your first 2 problems are done. I want you to find a partner and walk through the next 2 problems, and then I would like for you to do the last 4 on your own. Okay?